Hello everyone. Today we are back with another type of video. In this video we will do a case study on the regression. If you follow this video till end, then you should know how to build the model from scratch and how to proceed any data from the start to the end and finally select the model with the best accuracy. So before we start, here are a few details about DataMonk. In DataMonk, we help students to prepare for different type of interview. We also provide study material on SQL, Python, R, statistics, case studies, and machine learning. So, if you want to know more about the DataMonk, then you can visit our website www.thedatamonk.com. So, let us start with the case study. First of all, we will know about what do you mean by supervised machine learning. So, in supervised machine learning, it is where you have input variable X, output variable Y, and you can use an algorithm to learn the mapping function from the input to the output. The goal is to approximate the mapping function so well that when you have the new input data, then you can predict the output variable y for that data. And supervised machine learning problem can be further grouped into regression and classification problem. So in this video, we will talk about the regression problems. So first of all, what do you mean by regression? So a regression problem is when the output variable is a continuous numeric variable such as sale, dollar, weight. Like if a company has provided you with a data and asked to predict the sales for the future references, then you should use regression models. So as you have already seen, so for supervised machine learning, it is divided into two-part regression and classification. In regression, we predict sales or turnover, and in classification, we predict the classes. So for regression and classification, we have different type of model. So for regression, we have linear regression, decision tree, random forest, AdaBoost, XGBoost, KNN, and SVM. And for classification, we have logistic regression, decision tree, random forest, AdaBoost, XGBoost, KNN, SVM, and another type of algorithm which is naive Bayes. So let us start with the regression. So in regression, it is basically we provide prediction to below kind of questions like what will be the approximate price for this old car, or how many passenger will travel with our airline next month, or what will be the sales in the next quarter. So this all are the type of the regression problem, and in this video we will do one case study in which we have a data for the diamond, in which we have carat of the diamond, cut of the diamond, color, clarity, and extras, and we have to predict the price for this diamond. So first of all, we will explore the data in which we will find the relationship between our predictor variables and the target variable. And after finding the relationship between the predictor variable and target variable, we will build our model for the future reference. And in future, if you give us the data of carat, cut, color, clarity, then we can tell you the price for the diamond. So now let us start with our case study. And to build any model, first we have to explore our data. And to explore our data, first we have to read our data set. So to read our data set, we have imported two libraries, Panda and Numpy. So as you can see, this is the alias name we will use in our code for time saving. So now we have read our data using the read CSV function. So as you can see, pd.readcsv, and this is the address of our file. And then after that, we will delete the duplicate rows, if any, in our dataset. So first of all, we have printed the shape of our dataset. Then after that, we have used the drop duplicate to delete the duplicate rows, and then we have again printed the duplicate rows. So as you can see, this is the shape of our before deleting the duplicate values, and this is the shape of our data after deleting the duplicate values. So in this, as you can see, now we have 53,794 rows and 10 columns. So for 10 columns, there are price, carat, cut, color, clarity, depth, table, and the dimension of the diamond. So after that, we will observe our data using the info function, and from info function we can observe the summarized information of our data. And as you can see, now we can see our data type of every variables and how many normal values are there in every column. So as you can see, this is the data type of our every column, and for normal values you can see that in our color and in our depth there are some missing value which we will read afterward. And you should also remember that if any column has more than 30% of total data entry, then we should remove that column while building our model. So after that, we will see our statistical distribution of our data. So to see the statistical distribution of our data, we use describe function, and we have used include.all for our all variables. So after using this function, we can see the minimum value, maximum value of our data, 25%, 50%, 75%, and every quarter of our data. We can also see some unique value in our data. As you can see in our cut, clarity, and color, we have some unique values. So from this, we can also say that they are our categorical variables. Then after seeing our statistical distribution of our data and seeing the data types, we will observe the distribution of our target variable visually. So for visualizing our target variable, first we have imported our Seaborn library as SNS and then plot our distribution chart. So as you can see, this is our distribution chart for our target variable. In this, you can see that our data is positive skewed. You should also remember that when performing the regression, make sure that there is no zero in the target variable, as it will cause divide by zero exception later on while we are calculating the accuracy of our data set. So in this, as you can see, there are no zero value. Therefore, our target variable is good to go. Then after that, we will use any unique function to see how many columns are our categorical and how many columns are our continuous variables. So as you can see, they are the unique value of our dataset in which our price is our continuous variable. That's why we are doing the regression model. And for caret, depth, table, and the dimensions, they all are our continuous variables. And for cut, color, clarity, they are our categorical variables. Then after seeing the distribution of our target variable and the distribution of categorical and continuous variables in our dataset, we will visualize every column individually. So to visualize every column individually, first we will visualize categorical predictor using the bar plots. So first of all, you should remember that to visualize any categorical variable, you should group that variable for using the bar plots. So as you can see, we have grouped the data using the group by function for our cut variable. So as you can see, in cut we have 5 unique values which are fair, good, ideal, premium, and very good. And these are the distribution of the unique value of our cut. Then after that, we have written a function to plot the multiple bar charts for our categorical variables. So as you can see, in this function, we have to send our input data and the columns which we have to plot. So after that, you can see these are the bar chart for our categorical predictors. So in y-axis, these are the distribution of categorical predictor, and for x-axis, this is the categorical predictor. So as you have already seen that in cut we have 5 different unique value, and in color we have 7 different unique value, and in clarity we have 8 different unique values. So now you can see our distribution, they are fairly distributed for our dataset. Then after visualizing the categorical predictor, we will visualize the distribution of our numeric predictor variable using the histogram. So to visualize our numeric predictor variable, first we have written the data.histogram and then we have sent our continuous predictor variables. So as you can see, we have sent our dimensions, depth, and table. And for fixed size, this is the whole dimension of our this graph, big graph. Then after that, we will also see how to write the code for the distribution chart. So for distribution chart, we will use our Seaborn library and then we will plot our distribution plot. So now you can see this is the distribution plot of our caret. In Seaborn, it also outline our distributions. So you can see this is the outline of our chart. So after seeing the distribution of our individual variables, we will see the relationship between our variable in visualization. So to see in visualization, we have divided into 3 parts, like for continuous versus continuous, we can use our scatter plot. For continuous versus categorical, we can use our bar plot and box plot. And for categorical versus categorical, we can only use our bar plot. So first of all, we will see the relationship for continuous versus continuous. So for continuous versus continuous, first we have plotted our scatter matrix. So in scatter matrix, you should remember that there should be no more than 10 variable, as it can take time to plot every single graph in our dataset. So as you can see, this is the scatter matrix of our distribution. In this, it has plot every variable to the other variable in our dataset. So as you can see, we have to focus on our price and other variables. So this line is more important than other line. So you can see our distribution, like for price versus price, this is the distribution, and for price versus other variable, these are the distribution. And in this, scatter matrix only plot for numeric variables in our dataset. So after the scatter matrix, we will see our reg plot with x equal to caret and y equal to our price. So basically this graph is maximized version of single plot from this. Then after seeing the reg plot, we will get a plot for every individual relationship for price versus other variable. So we have plot our scatter plot for caret versus price, for x versus price, and for y versus price. And in this scatter plot we can also observe our outliers. So as you can observe, there are two outliers in our y dimension which are above 30. Like this is our outlier 1 and this is our outlier 2. So if our data set is small, then it should be advisable to remove this record or replace it with a logical values which is nearby to the similar records according to our dataset. So in this we will treat our outlier. So first of all, to treat our outlier, we will find those rows where y is greater than 30. So you can see we got our two rows where we have y greater than 30. So after that we will replace this value from the logical value. So you can see in our data the maximum value is around 11 or 12. So we will assign it as 13. So now you can see the description of our price variable. So after that you can also see the scatter plot after the outlier treatment. So now you can see our maximum value which was above 60 is now at 13. Then after seeing the relationship between the continuous versus continuous, we will see the relationship between the continuous versus categorical. So to see the relationship between the continuous versus categorical, we have already seen that we can use our bar plot or our box plot. And as we have already discussed that when we have to plot our categorical bar plot, we have to group our data. So first of all, we will group our data with a cut variable. So in this table, you can see that in cut we have 5 unique value which we have already seen, and these are the mean values for every other column. Like for cut equal to fair, our mean value is our 4341, and for every other column. Then after grouping the data, we can plot the relationship between the cut group data and the price. So now we will plot this data. So now you can see we have plot the bar plot. In this, it tells us the average price for each cut. Like for cut fair, our average price was our 14,341, and for cut ideal, our average price was around 3,500. So you can see in our data it is around 3,500. So after seeing the relationship between our price and cut, now we will see the relationship between our color and the price. So now you can see the relationship between our color and price, and this bar plot tells us that this is the average price depending on the color of the diamond. So like if our color is D, then our average price will be around 3,000. Then our price will be more than 5,000. So from this you can see our price is highly dependent on our color variable. So after plotting some bar plot, we will plot our box plot using our Seaborn library. So now this is our box plot for our cut variable, and in box plot it is also used for observing the outliers. So as you can see in this data we do not have any outlier, but in some cases we can easily observe other outliers. So after seeing this box plot, we will plot relationship between price and other variable. So now you can see first we have grouped our clarity variable and then printed the unique values and then plot our count plot and our box plot. So now you can see this is our bar plot and this is our box plot. And by using our Seaborn library, you can get some colorful visualization for our datasets. So now you have already seen the relationship between our dataset with the help of the visualization. So now we will see the relationship between our variable using the statistical measurement. So for statistical measurement, we again have three types. Like for continuous versus continuous, we use our correlation matrix. For categorical versus continuous, we use ANOVA test, and for categorical versus categorical, we use our chi-square test. So first of all, we will plot our correlation matrix for continuous versus continuous. So in correlation matrix, you should remember that if our value is greater than 0.4 or 0.5 or less than minus 0.4 or 0.5, then it shows that our target variable is somewhat related to our predictor variable. So for correlation matrix, we have first find the correlation between the data and then plot them using our heat map. So now you can see this is the heat map of our correlation between our variables. So in this heat map, as you can see, we have to ignore the purple values as it is between 0.4 and 0.0, and we can consider our light colors and black colors as it would have high correlation values. So as you can see for our light color, we have relationship between our price and our dimensions, and from this correlation matrix we can also see that our depth and table do not have high correlation with the price. Therefore we will neglect these two variables while building our model. So we will consider our only dimension as our continuous variable for our further references. So now you have seen the relationship between our continuous versus continuous. So we will see the relationship between our continuous versus categorical. So for continuous versus categorical, we use our ANOVA test. And in ANOVA test, it performs on the basis of hypothesis testing. And in hypothesis testing, we take our H naught as our assumption. Then that means we will consider that there is no relationship between the given variables. So if our p-value is greater than 0.05, that means 5%, then we will consider that there is actually no relationship between our given variable. So for that, first we will calculate our p-value for our color, cut and clarity. So as you can see, for our color, we have got p-value equal to 0.0. Then that means we have high dependency between our color and the price. And for cut and clarity, it is very less than 0.05. Then that means that we will also consider our cut and clarity while building our model. So now we have used our statistical feature selection for our continuous versus categorical and continuous versus continuous. So now our variables are ready for our model, but after seeing the areas for our data, there is one main process which is data pre-processing. So to pre-process any data for machine learning, we have five simple steps. First is to treat the missing value. Second is to treat our outlier. Third and fourth is to convert our ordinal and nominal variables to our numeric variables. And fifth is to standardize and normalize data if our data values are very large. So first of all, we will treat our missing value in our dataset. So to treat any missing value in our dataset, we first have to find which variable contains the missing value. So from this, we have printed data.isnr.sum, and now you can see the missing value in our dataset. So in color and depth, we have 6 and 14 missing values. So we will treat them, and to treat them, we have used the interpolation method. And for numeric variable, we have used interpolation method of linear. And for categorical variable, we have used interpolation of method FL. So now after treating the missing value for color and depth, so now you can see that in our dataset, we have no missing values. So after treating the missing value, our next step is to treat the outliers. So as we have already seen that we have already treated the outlier for our y and the price. So now we will treat our outlier for another dimension. So first of all, we have plotted our scatter plot and distribution plot for x and z dimension. In x, you can see some outlier which are at 0, which will be not possible for the dimension of our diamond. So now we will treat our x equal to 0, but before we treat them, you can see our correlation between our price and x, which is at 0.8845. So after treating the 0 values, our correlation between our price and x should increase. So now we will treat our outlier, and to treat our outlier, first we have to find which are our outlier. So now you can see these are our outlier where our x and z are zeros. Therefore, they all are our outliers. So we will treat them logically. So for x which are 0, we have assigned the lowest value which will be 3. So as you can see, we have assigned the x equal to 3, and then find the correlation between our price and x. So now you can see our correlation between price and x, which will be 0.8861, which is increased but by very little margin. And for y and z dimension, we will do the same. So after treating the outlier in our dimensions, we will convert our categorical data to our numeric data. And to convert our categorical, we have two type of categorical. First is our ordinal variable, and second is our nominal variables. So first of all, before treating the nominal variable, you should remember that you should have to treat ordinal variable by manually mapping the numeric variables. So in this, as you can see, we have manually mapped our cut variable to numeric variables. So for ideal, we have assigned the value 4. For premium, we have assigned the value 3. For very good, 2. For good, 1. And for fair, 0. And you can also see in our database cut equal to 4, 3, 1, 3, 1, which are all numeric variable. Then after that, before using the dummy variable, you should remember to drop the useless columns. So before using the dummy variable, we have dropped our useless column, which are depth and table, as they show very less relationship with the price. So after dropping the useless column, depth and table, we will use our dummy function. So now after using the get dummy function, you can see our head of our data. Now our data has 21 columns, means that our nominal variables are divided into individual variables like Like for color, it is divided into color D, color E, color F, color G, and depending on how many unique variables are there in the variables. So now you can see our new data set. We will use this data set to build our model. So now our data is ready for our machine learning algorithms. But before we start, we have saved the processed data as our pickle file, as it is good practice to save the pre-processed data for future references. So after saving the pickle file, now our data is ready for splitting into two parts, training and testing sample. So you should remember that we don't use the full data for creating the model. Some data is randomly selected and kept aside for checking how good the model is. This is known as our testing data. And the remaining data, which is used for building our model, is known as our training data. Typically, 70% of the data is used as our training data, and the rest 30% is used as our testing data. So after that, we will use data numeric.columns, which will give us the columns in our dataset for our further references. Then after that, we will assign values to our target variable and the predictor variables. And after assigning the values to our target variable and the predictor variable, we have split our data into training and testing set. And to split our data, we have to import the library train test split from sklearn.model selection. And we have split our data in the ratio of 70% as our training data and 30% as our testing data. And for random set, it is just the number which tells us that we have picked our data in random order from our dataset. So in this, you can also see that our predictor is only one, because first of all we will do our single linear regression model. From single linear regression model, we will see how can we predict our target variable with using only x dimension. So before that, you can also see the shape of our data. So in this, you can see that in predictor columns, we have only used one variable, and we have split our data into four parts: X-train, Y-train, X-test, and Y-test. And this is the total number of X-train, Y-train, X-test, and Y-test. After splitting our data into training and testing sample, our data is ready for our simple linear regression model. So to use simple linear regression, first we have to import our linear regression library. So now you can see our first step is to import our library. Then we have created our model, which is reg model, using the linear regression function. Then you can see that in linear regression we have zero hyperparameter, and as we go further into complex algorithm, we can observe that our hyperparameter will only increase. So after creating our model, we will fit our data from X-train and Y-train and then predict using the X-test. Till now, a simple linear regression is ready. Now we will see the goodness of it for our training data and our accuracy for our testing data. So now you can see our R2 value is 0.78 and our accuracy on our test data is 34.17. So now you can see this is our data set. From X we have predicted our price, and this is the actual price. So in simple linear regression, you can also see the value of the slope and the intercept using the coefficient and intercept. So this is the value of our slope and intercept, and simple linear regression simply predict our price using this equation. Now we will see the equation of this line. So now you can see this is the equation of this line. Then after creating our linear regression model and noting the accuracy of linear regression model, we will go further and use other sophisticated algorithms. So to use any other algorithm apart from our simple linear regression, first we have to sample our data for multiple predictor columns. So now you can see in our predictor, we have assigned our every column to our predictor array, and our target variable will remain same. So you can quickly check the shape of our X-train and X-test, which tell us that we will use 20 columns now. So let us see what accuracy the multiple linear regression give us. So for multiple linear regression, we have used multiple predictor and then we have created our model. The code will be same as our linear regression. The only change in for multiple linear regression and simple linear regression is the number of predictor we are using in our X-train and X-test. So this is our multiple linear regression. So you can see the accuracy for our multiple linear regression. It comes to be 61.11%, which is increased by a lot in comparison to the single linear regression. So that's the data set, and this is our predicted price for multiple linear regression, and this is our actual price. Then after the multiple linear regression, we have used n-fold cross validation score. So for n-fold cross validation score, it split the data into the n parts and then iteratively use one part for testing and other part for training data. It is a good practice to use n-fold cross validation because sometimes we can pick our favorable data or unfavorable data. So it can affect our accuracy by a lot. So by using the n-fold cross validation score, we can make sure of that we are making every combination of data as our training data. So we have written the n-fold cross-validation function. So in this you can see that we have done 10-fold cross-validation as our CV equal to 10. And you can see that in tenfold cross validation score we have got very different accuracy, like sometimes we get 61% or sometimes we get 29%, so it can vary a lot. Therefore we will take the average of all this accuracy and it will be our final average accuracy for the model. So for multiple linear regression, our final average accuracy comes to be 57.84%. We can do n-fold cross-validation in our every algorithm. So after noting the accuracy for our multiple linear regression, we will see how much accuracy does decision tree give us. So for decision tree, here is the code, and in decision tree, now we have two parameters to fill in. So for decision tree, our first parameter is max depth, which is the height of the tree, and the criteria will be mean squared error. So for regression, we use criteria equal to MSE only, and for classification, we can use criteria equal to entropy. Then after filling the hyperparameter, for max depth equal to 3 and criteria equal to MSC, we get our accuracy as 76.81%. So we can also hypertune our max depth like 2, 3, 4, 5, 6, 7, 8, 9, 10 and see which height gives us the maximum accuracy. So for seeing the decision tree, I have taken max depth equal to 3 because if I take max depth equal to 7 or 8, then our tree image will get very small and we can't see it. So for decision tree, I have taken max depth equal to 3, and in decision tree, most of the code is same as our multiple linear regression. The only change is in our feature importance chart. So this is our feature importance chart. So in this you can see that we have plotted our bar plot, and in this you can also see that caret carries the highest bifurcation power in our whole data set. So caret will be our root node followed by our y and clarity si2. This is our feature importance chart and this is our database, and here is our predicted price and our actual prices. Then after seeing the decision tree model, we will plot a decision tree of height 3. So now you can see the decision tree of height 3. So we have plotted decision tree of height 3 using our image entry and our pi dot plus. So first we have to create the dot data for the tree. Dot data is just the information which we have to fill in the tree, and then after that we'll create our tree and display it. So this is our tree, and this our caret less than 0.995 is our condition. Our MSE is our mean squared error, and for sample it means that total number of rows, and for value it is just the average of the samples. So if the condition is true we will move toward this, and if condition is false we will move toward this, and same for all the nodes. So in decision tree we got our accuracy as 76%, which is till now the highest. So after that, we will plot our random forest and note down the accuracy. So for random forest, now we have three hyperparameter. You should also know that our random forest is a type of bagging of multiple decision trees. So in this we have new type of hyperparameter which is n estimator. So for n estimator, it means that we will build 200 decision trees and then take the average of all the 200 trees and give our final score. So for random forest, our max depth will be equal to 7, which will be the height, and criteria will be MSE for the regression. You should also note that the good range for max depth is 2 to 10 and an estimator is 100 to 1000. So you could tune your hyperparameter with respect to the accuracy. Then after that, our code will be same as our decision tree. In this, we will again have our feature importance chart. So you can see our feature importance chart. In this, as you can see, like in decision tree, our caret carries the highest. Then it was y, then clarity S12. But we do not consider any importance for our clarity I1 or color J or X dimension. But in random forest, as we consider 200 decision tree, so in some decision tree, it will carry some importance. Therefore, for average importance, there are some importance in color I or clarity I1. So you can also see that our accuracy for our random forest is 86.53, which is increased by a lot in comparison to our decision tree, which was 77% only. Therefore, till now, our highest accuracy is our 86.53%, comes from our random forest. Now we will plot our decision tree out of all the 200 decision tree that we have created in our random forest. So to create a decision tree, we again need a dot data. Then after that, we will draw our data and show the image of our data. So in this, as you can see that we can't actually see our decision tree. It is only in the form of this because now our decision tree is very big as the height of decision tree is 7. So after seeing the random forest, now we will see the adder boost and what accuracy do adder boost give us. So for adder boost, it is just the boosting of the random forest. So for adder boost, first we will create a decision tree and then we will boost it. So in this adder boost, we will create a decision tree of height 5, as you can see in our max depth equal to 5, and for boosting we will assign base estimator to our decision tree. Then after that, an estimator will be same, which is we will make 200 decision tree and find the average of all the decision trees. And for learning rate, it controls the loss function used for calculating the weight of the base model. So basically it tells us that how much improvement we should do with respect to our previous decision tree. Then after assigning the value to our hyperparameter, we can notice that our code will remain same as it was in our random tree or decision tree. And for tree type of algorithm, feature importance chart is necessary to see which will be our root node or which will be our leaf node. So for feature importance chart, you can see that this is our feature importance chart, and in this our OR variable carries some bifurcating power. So for adder boost, our accuracy come to be 80.34%. But if we increase our max depth from 5 to 7 or learning rate from 0.09 to 0.05 or 0.01, then we can get high accuracy in our adder boost model. Our random forest gave us the highest accuracy, which is 86.67%. So after creating our adder boost model, we will see the decision tree of the adder boost model. So for decision tree of the adder boost model, our process will be same. First, we have to create our dot data and then draw the tree and show the tree. So this is the decision tree of height 5, and for data in this, it will be same as our decision tree as it is also a decision tree. So now we will create our XGBoost model and see how much accuracy does XGBoost give us. So for XGBoost model, first we have to import our library XGB regressor from our XGBoost, and in XGBoost regressor, you can see that we have 5 hyperparameters. So as we are moving into complex algorithm, our hyperparameters are only increasing. So for XGBoost model, we have 5 hyperparameters which are max depth, learning rate, n estimator, objective, and booster. So for max depth, learning rate, and n estimator, it is same as our adder boost. The change is in our objective and our booster. So for objective equal to regression linear, it tells us that we are doing the linear model, and for booster equal to GB tree. So GB tree is one of the best booster. Therefore, we have used our booster as our GB tree, which will help us in boosting our decision tree. So in this, as you can see, we have assigned max depth equal to 3 and learning rate as 0.1, and where our n estimator is 200 and objective and booster will be fixed. So apart from the hyperparameter, you can again notice that our code will be same. Our code will be same for our XGBoost or AdaBoost or random forest or decision tree. In this, as XGBoost is again a decision type of algo, therefore we have used our feature importance chart. So you can see the feature importance chart for our XGBoost. So in this, as you can see now, our Y carry the highest importance, which means that Y has highest bifurcating power to divide our data set into two parts. So this is our data set, this is our predicted price, and this is our actual prices. Till now, XGBoost gave us the best accuracy, which is 88.18%, and it is only natural as it is the advanced version of our random forest and decision tree and adder boost, which is our extreme gradient boosting. So after noting the XGBoost accuracy, we will plot a single decision tree out of 200 decision tree in the XGBoost model. So this is the XGBoost tree. In this, we have only one condition like F12 or F3 and F1. So what do you mean by F12, F3, F1? They are just the feature. Like in this, our caret will be our F0, cut will be our F1, X will be our F2, and so on. And for leaf node, it is just the node in which we have to take the summation of all the 200 tree or 500 tree depending on how much tree we have built to get the actual value of the price of the diamond. So after seeing the XGBoost tree and noting down the accuracy, we will see our KNN model. So KNN is the k nearest neighbor, and surprisingly, it only need one hyperparameter, which is n neighbor. So for n neighbor, as the name suggests, it tells us that how many neighbors we should consider while creating the cluster. And apart from our hyperparameter, all the code will be same. And from KNN, you can see that we are getting accuracy as our 92.04%, which is our highest accuracy till now. So now this is our predicted price and this is our actual price, and you can actually notice that it is very close to our actual data. As you can see, we have predicted our price as 1860, which is actually 1851 only 9 points difference. So you can also see that our accuracy is 92%, which is actually very high. Then after creating KNN and noting down the accuracy, we will move toward our last algorithm in our regression model, which is support vector machine or SVM. So for support vector machine, there are actually four hyperparameters, which are C, kernel, degree, and gamma. So what do you mean by C, kernel, degree, and gamma? So for C, it tells us that we are allowed to make 1000 misclassification in our dataset. And for kernel, it is just the radial basis function RBF, which tells us that our model will be non-linear. And for degree, it tells us that how much non-linear should it be. And for gamma, it is just the learning rate of our dataset. So after assigning the value to C, kernel, degree, and gamma, we'll create our model. And apart from hyperparameter again, our code will be same as our previous algorithms. So from SVM, we are getting accuracy as our 91.99%, which is very close to our KNN model, which was our 92.04%. But finally, we will consider our KNN model for this dataset as it gives us the highest accuracy. So hence our KNN will be the best model for this dataset. Then after KNN, it will be our SVM as it is very close to 92%. So that's all for the video. Thank you for your time. Hope you like the video. For more amazing content and algorithm type of videos, do like and share the video.